Hello guys, welcome to Ramta Solutions and welcome to your grade 12 mathematics. Today we are looking at logarithms and of course we are introducing logarithms. Guys, please know that these are not really dealt with extensively in grade 12, but we have seen that in some question papers your knowledge of logarithms is very key. And I believe you will see it or you have seen it in your inverse of functions. Okay, especially the inverse of your exponential graph. Okay, so without any waste of time, let's look at them. So now, something that you need to know is this, is that logarithms are inverses of your exponents. Okay, they are inverses of your exponents. Okay, now to not waste time, I want to show you something. You have this functions in your calculator. Your calculator has this key here, and then it also has this key. Okay, it also has this key. Whether you are using Casio or you are using Sharp, all of them, and any other brand of a calculator that you're using, all of them has this function. Okay, all of them has this function. Okay, they may look different, but all of them have this function. Okay, so I want us to try something, guys. I want us to try this guy here on our calculators. We're going to calculate the value of log 0, the value of log 1, the value of log 10, and the value of log 100. Okay. While we are on it, we will also calculate the value of log 0 base 10, the value of log 1 base 10, the value of log 10 base 10, the value of log 100 base 10. Okay, so let's go to our calculators and let's see what we are getting. So let's begin with log 0. Your calculator will return an error. Now let's go to log 1. Your calculator will return 0, sorry, not 1, it will return 0. Let's go to log 10. Calculator returns 1. Let's go to log 100. Your calculator returns 2. Isn't it? It returns 2. Right? Perfect. Now let's look at these ones here. Log base 10, log 0 base 10. Again, your calculator returns an error. Log 1, it returns 0. Log 10, it returns 1. Log 100, it returns 2. Okay, so this is your normal log or your normal logarithm. Okay, now this normal log, it's assuming that the base is 10. Okay, it's assuming that the base is 10, right? Right. So, remember guys, I said logarithms are inverses of your exponents. Okay, they are inverses of your exponents. I want you to see that there's a trend here. Let's perhaps start with 1 to 10. There's a trend. Log 1 is 0, log 10 is 1. So this means log 2, 3, 4 until 9 or whatever, it'll be 0 comma something. Maybe let's check on our calculator. Let's try log 8. It'll be 0 comma something. You will see. Log 8, 0,903. All right, 0,903. Right, but there is no, we are not interested in this. Okay, so you have seen log 1 is 0, log 10 is 1, log 100 is 2. Okay, remember we are saying that logarithms are inverses of exponents. We are going to revisit this shortly. Okay, or later, not now, but later. And I want you now to see that when we say log 0 base 10, when the bases are 10, we get the same answers like we got here. So this, when you see log without a base written here, you must know that the base is assumed to be 10. This is your normal logarithm. Okay, this is your normal logarithm. Okay, perfect. Now, there are what we call special cases. There are what we call special cases when it comes to logarithms. Guys, one thing you know is this. You guys know that a to the 0 is 1. And you also know that a to the 1 is similar to saying a. Now, when we do logs, it's similar to saying log 1 base a is 0. Right? Log 1 base a is 0. And here, we will say log a base a is 1. Right? So, you see, when you say log a base a is 1, when the base and the power are almost the same, you get the same answer. Okay, sorry, it is equal to 1 because this is 1. Okay, so when this is like this, you get 1. When it is like this, you get 0. Okay, so these are your special cases of your logarithms. Okay, these are your special cases. Okay, as you can see, this is the relationship from exponents. So this is what you have been doing, or what you will be doing in your inverse functions of your, or on your inverses of your exponential graphs. Okay. All right. Now, logarithms have rules. Okay, they have rules. You don't need to know them by order, but knowing them is good. So rule 1 will be log, let's say log xy base a. It is similar to saying log x base a plus log y base a. We are going to have a video where we're proving this, but this we will do later on, guys. For right now, because we are close to exams, we don't have to prove this. But in the course of the year, for sure next year, we will be proving this. Okay, for enrichment only. Rule 2, I will explain this. This is basically the product rule. Another rule 2 is log, let's say log x over y base a. This is log x base a minus log y base a. Rule 3 is log x to the power b base a is equal to b times log x base a. Rule 4 is log x base, let's say base a, is the same as, maybe let me not say a, let me say y. Yeah, let me say log x base y is the same as log, I'm going to say a, log x base, come on buddy, log x base a over log y base a, or simply it is the same as log x over log y. Okay, it is the same as log x over log y. Okay, guys, these are the rules. These are the rules that we encounter regarding these are the rules that we have for logarithms. Okay, these are the rules that we have for logarithms. Okay, these are the rules that we have for logarithms. Okay, guys, so we are going to try some examples. Okay, we are going to try some examples so we familiarize ourselves with these laws. Let's see. Example 1, expand. It's going to be expand the logs. Okay, expand the logarithms. Okay, so a will be log 3x base 8. B will be log 6 over x base 8. C will be log x to the 4 base a, and then d will be log, let's try, 2m squared over m base what? Base what? Can say base 5. Okay, maybe let me change this one here to be, yeah, base 5. Let me make it n. Okay. Okay, base 5. Okay, base 5. Okay, so we can, I think we can answer them here. Is it possible? Yes, it is possible. So with this one, it looks like I'm seeing the rule 1. So what is this? This will be log 3 base 8 plus log x base 8. Right? Happy? Now, looking at this one, it seems like it is rule 2. What is that? Log 6 base 8 minus log x base 8. Let's go back to confirm. Indeed, rule 1 and rule 2. Okay, perfect. Let's look at number C. It is, seems like it is rule 3. So it must be 4 log x base a. Isn't it? It must be 4 log x base a. D, it looks like it'll be log 2m squared base n minus log n base 5. Sorry, base 5, not base n, base 5. Okay, base 5. Right? And this, it seems like we can simplify this. Further simplification, it'll be 2 log 2m base 5. Let me do this. 2 log 2m base 5 minus log n base 5. Right? Log n base 5. Right? Great stuff. Okay, so this is it, guys. This is our logarithms, okay? This is logarithms when we are expanding them. Now, let's try another example. Example 2. AG2, we're going to say simplify. Okay, we're going to say simplify. So what do? We're going to say simplify A. It's going to be log 2 plus log 5. B, it's going to be log 32 base 2 minus log 4 base 2 minus log 1 base 2. C will be 2 log 5 plus 3 log 2, 3 log 2 minus 1 over 3 log 8. D will be, let's try log 9 minus log 3 over log 9 plus log 3. Now let's get our solutions. So now let's see what this will be. A, for our solutions, let's look at A. A was log 2 plus log 5. This looks like we are looking at rule 1. Let's remind ourselves, rule 1. Do you see this? So we can say the bases are the same, right? The base is 10. Remember, if we don't write a 10, we do say that it is a 10. So we can therefore say this becomes log 2 times 5. And what is this? This is log 10. Now, if this is log 10, remember, guys, we said log 10. It somehow, if this is 10, this must be 1, right? This must be 1, and I will explain. This is because we see this as 10, 10. So when you have this form of a log, it becomes 1. Okay? Right? Comes 1. Perfect. Now, let's look at question B. It is log 32 base 2 minus log 4 base 2 minus log 1 base 2. So this becomes 32. We know it to be 2 to the 5. So it'll be log 2 to the 5 base 2. 4, we know it to be 2 to the 2. So it'll be log 2 to the 2 base 2 minus log 1. Because I see here it's been 2, 2. We can also say this is 2 to the 0 base 2, isn't it? Now, rule 3, right? We are applying rule 3. Let's remind ourselves, we are applying rule 3. Let's go. So this then becomes 5 log 2 base 2. Remember, we dropped the 5. Now we drop the 2. 2 log 2 base 2. We drop the 0. 0 times log 2 base 2. What is this? This becomes 0. So this will be 3 log 2 base 2. Remember, guys, this part becomes 1. So this is similar to saying 3 times 1. Therefore, our answer is 3. And by the way, for this section that we are doing, you can directly press this in your calculator. It'll return 1. Okay, you can directly press this in your calculator. It'll return 1. So this was using rule 1, and this is using rule 3, right? Okay, so the reason why I didn't say this over this is because, guys, as you can see, it's log 2 base 2. These are the same thing. So like terms, you add and subtract, right? Now, question C, we are dealing with 2 log 5 plus 3 log 2 minus 1 over 3 log 8. Now, what we need to do, we are tempted to consider this. Yeah, it's tempting to really take this to say, I don't know, but right now it's tempting to use rule 1. But we cannot use rule 1 because we have 3's and the stuff, right? We have 3 and whatever. So hold on for now. We need to fix this guy here, okay? We need to fix this guy here. So I'm going to leave it like this. 2 log 5, okay? I'm going to say 2 log 5 plus 3 log 2 minus, this guy will be 1 over 3 log 8 is basically 2 to the 3, all right? And what is this? This is 2 log 5 plus 3 log 2. This becomes now log 2, right? Because what has happened? We have dropped the 3. So it'll be 3 times 3 log 2. As you can see, this becomes 1, right? Now, look at this. We have like terms here, right? So we have 2 log 5 plus 3 log 2 minus log 2. It'll become 2 log 2. Oh, we have a common factor of 2. Let's take it out. 2, we are left with log 5 plus log 2. Now, what is happening? This, do you see now that log 5, now we can apply rule 1. Remember, here we applied rule 3, right, for this one in particular. Now we apply rule 1, so it will become log 5 times 2, right? This is applying rule 1. This then becomes 2 log 10. By the way, guys, we know that if we have no base written, we take it as a 10, right? Your calculator will give you that this let me proceed in there. So 2 log 10 is similar to 2 multiplied by 1. Our answer is simply 2. So your calculator, when you press this expression into your calculator, it'll give you 2. Okay, it'll give you 2. Proceeding. Let's go to question D. So question D is log 9 minus log 3 all over log 9 plus log 3. All right. So now, what do we do? It's indeed tempting. So we'll say, let's use 9 and 3. 9, we know it's a power. It's 3 squared, isn't it? Good. So this will become log 3 squared plus minus log 3 over log 3 squared plus log 3. What is this? This is now 2 log 3 minus log 3 all over 2 log 3 plus log 3. Now, as you can see, we're collecting like terms. What does it mean? 2 log 3 minus log 3 becomes 1 log 3. 2 log 3 plus 1 log 3 becomes 3 log 3. These logs are cancelling. Okay? These logs are cancelling. So what is our answer? Our answer is simply 1 over 3. Okay? Our answer is simply 1 over 3. You can also do it using the different rules. For example, perhaps using rule 1 and rule 2. It will still give you the same answer. Okay, it will still give you the same answer. So with this being said, it's a wrap, guys. I do hope that you now have an idea of what you are doing when it comes to logarithms. Okay, when it comes to logarithms, I hope that you now have an idea. But stay tuned for the next video where we will be solving equations using logarithms. Okay, now remember, if you would like to get in touch with us, you can visit our website www.ramtasolutions.co.za. At the top on our website, you will see all these icons. These 3, you can click on them to follow us on your favorite social media platforms. And for sure, you are watching this video on YouTube. If you are watching on YouTube or wherever you are, and it's from our official channels, please follow, like, and subscribe. And of course, if you are looking for a tutor or you want to ace that exam ASAP, please contact us so we can assist you with your topic of choice. And please, may it be your parents that are contacting us, guys. Okay, let your parents be the ones that are finalizing with us, guys. All right? So with that being said, it's a wrap and bye-bye.